Hello everyone, it's Evan Ellison here, and today we're going to be talking about solving linear equations using the elimination method. Now, if you don't already know, you've solved these types of equations, well, of course, in a simpler form when you were younger. You just didn't know it. So you're probably thinking, Evan, what are you talking about? Well, what I'm talking about is that when you were younger, you were probably given a problem that looked just like this. Blank plus 9 equals 11, and you would just place a 2 in there. What you're going to be working on today is called systems of equations, and what systems of equations is basically a collection of two equations with the same unknown. So I'll give you an example of a problem of what we'll be working on today. So you'll have x plus y equals 14, and you'll have 3x minus 2y equals negative 15. So that's what we're going to be working on today. But you're probably thinking, Evan, how do you transition from the blank plus 9 equals 11 to systems of equations? Well, I'm going to tell you something that kind of proves there's no real transition. So here we're going to have x plus 3 equals 13. That will work. That's an equation because you can just minus 3 on both sides. And that'll give you 10 plus 3 equals 13. So that's a proper equation. That'll work. But you can't have two variables in one equation. You could have two variables in two equations, but you cannot have two variables in one equation. And I'll show you why. Here, let's put A here for now. Because there's so many answers for the x's and y's, you can't use it. Because there would be so many answers that would be correct. There's 4 plus 4. There's 7 plus 1. There's 6 plus 2. You can even go into decimals. You could have 0.5 plus 7.5. There's 1.5 plus 6.5. So that's why when you have two variables, it'll always get two equations. And if you have one variable, it'll always be one equation, okay? Remember that. Also, remember that now you're dealing with the elimination method, a variable in both equations must have the same or opposite coefficient. And it's often necessary to multiply one or both equations by a constant. So let's get started with the problem, shall we? We shall. So we're going to have 2x plus y equals 10. And then we're also going to have 3x equals 10 minus 4y. So you're probably thinking, Evan, okay, let's get solving. Where do we start? Well, you cannot start because the x's and the y's and the constants need to be lined up. And what I mean by that is since they're not lined up, I'm going to bring that negative 4y over that equal sign. And it's going to be 3x plus 4y equals 10 since the 10 is already on the right side of the equal sign. And like I said earlier, it's often necessary to multiply one or both equations by a constant. So it will be, let me erase this. It will be 3x plus 4y equals 10. Okay? And like I said earlier, you got to multiply it by a constant. So I'm going to multiply this one by 3. And I'm multiplying, I can't see it on my screen. But I'm going to multiply the 3x by 2. And I'm going to multiply this one by 3. Okay? So it's both going to be 6x. 6x plus 3y equals 30. And then we're going to have 6x plus 8y equals 20. Now I'm going to minus it. During these, you can minus or you can subtract. Whatever, it's totally up to you, but you'll sometimes need to pick and choose because one or the other may not work. So I'm going to minus 6x minus 6x, that's gone, that's out of the way. And then we have 3y minus 8y, that's negative 5y. 30 minus 20, I will give you 10, equals 10. So negative 5y, since it's multiplying the y, you're going to divide it. So negative 5 divided by negative 5y, that cancels out, and 10 divided by negative 5, well, that'll give you negative 2. So y equals negative 2, okay? And you're probably thinking, okay, Evan, we're done. Move on to the next problem. No. Slow your roll there, okay? We're not done. We got to plug it back in so we can find out what the x is, okay? So instead of plugging in 2x plus y equals 10, since we already know that y equals negative 2, we're going to say 2x minus 2 equals 10. And then you're just going to plus 2 both sides. So I'm going to give you 2x equals 12. And then you're going to, cancels out. And then since the 2 is multiplying the x, you're going to divide it. So 2. So then 12 divided by 2, that'll give you 6. So x equals 6 and y equals negative 2. Okay? Well, next problem, okay? So we're going to have 3x plus 2y equals 9. And then we're also going to have 2x equals 4 minus 4y. okay? So we're going to bring everything so it's lined up and it's multiplied by everything, okay? So let's give you into a simpler form, so we're going to be starting off as. So we're going to multiply the top one by 2 and the bottom one by 3. So it's going to be 6x and 6x. And then we're going to have, since that 2y's multiplied by that 2, it's going to give you 4y. And then that bottom 4 multiplied by the 3, bottom 4y right here multiplied by the 3y is going to give you 12y equals 12 multiplied by the 4 multiplied by that 3 is a 12. And then you have 18, so you have 9 multiplied by that 2, so that'll give you 18 equals 18, okay? So now we can actually start solving. I'm going to minus it right away. Like I said, you just want to get these out the way. Elimination, you want to eliminate these from the problem. So you have 4y minus, oh, sorry, it's bad. That's supposed to be a 12 here. 12y. So that's going to give you negative 8y. And 18 minus 12, well, it's going to give you 6, okay? Equals 6. And then you're just going to divide it because the negative 8 is times the y. You're going to divide it. So 6 divided by negative 8, well, it's going to give you negative 0.75, okay? Like I said earlier, you're not done. You got to plug it back in, okay? So we're going to plug it back in. So we are going to have 3x, sorry, we're going to have 3x plus 2 multiplied by negative 0.75, it's a 5 there, equals 9. So we have, oh, sorry, I didn't put the 2 in there, plus 2. So 3x and then 2 times negative 0.75, that'll give you 2x minus 1.5 equals 9. And you're going to plus 1.5 on both sides. Plus 1.5, and it's going to be 3x equals 10.5. 3x divided by 10.5, well, it's going to give you x equals 3.5. When you're finished, you're never really sure if you're right. So let's go back and let's check our work, okay? So we're going to have, sorry, let me erase this. We're going to have 3 multiplied by 3.5, since that's what x equals, plus 2 multiplied by negative 0.75, that's what y equals 9. So we have 3 times 3.5, well, it's going to give you 10.5 plus, or let's just say minus 1.5, because it's plus negative 1.5, so we'll just say minus 1.5. Minus 1.5 equals 9. Well, that's pretty simple. You can just look at that right there. 10.5 minus 1.5, well, that equals 9. Thank you so much for tuning in to solving systems of linear equations using the elimination method. Thank you so much for looking into Evan Ellison at math.com, and I hope to see you again for another video next week. Have a good day. Bye.